Welcome to another episode of AI with Sally, an EE Times podcast that brings you inside my conversations with luminaries of the AI chip industry. Today's episode is brought to you by our sponsor, Infineon Technologies. In this episode, we're going to talk about how Infineon's PSOC Edge is enabling natural language processing directly in ultra-low power embedded systems. With advances in on-device AI acceleration, optimized memory hierarchies, and secure compute domains, PSOC Edge brings voice and language understanding to endpoints that previously relied on cloud inference. We'll discuss how Infineon's hardware-software co-design enables real-time NLP with minimal latency and power consumption, all while maintaining data privacy at the edge. Joining us today is Infineon's Omar Cruz, who will unpack the technical innovations and system design strategies driving this new generation of edge intelligence devices. Here's my conversation with Omar. Okay, Omar, welcome to the show.
Thank you, Sally.
So Infineon has taken this PSOC Edge product into production. This is Infineon's microcontroller family with hardware acceleration for edge AI. Tell us first about which markets are driving the need for hardware acceleration for AI in microcontrollers today.
Yep, definitely a great question. What I keep telling people is that with now edge AI, we are looking at new markets, right? But part of the traction that we've had with PSOC Edge is around specific or different types of target markets, right? We're seeing a lot of traction on edge AI around HMI applications. From the HMI applications, you can think about appliances, you can think about even in industrial space like device usability and also factory automation, right? Those type of applications. Now they're looking to the edge AI capabilities, taking things back to smart home, right? Thermostats, smart speakers, door locks. Of course, wearables, they have taken already a leap into the edge AI, but they now have gone even further. So think about fitness watches, augmented reality, mixed reality, virtual reality glasses, and audio accessories as a wearable. And then robotics, whether we're talking about consumer robotics or whether we're talking about industrial robotics, right? Like the ones that you can see in the industrial factory lines or the ones you can see at home, like the vacuum cleaners, right? All of those also, they are leveraging the edge AI capabilities that now we're able to bring. And then definitely last but not least is around monitoring and vision, right? So IP cameras, battery operated smart doorbells, as well as security cameras. This is something that we're putting a lot of emphasis. This is something that we're seeing a lot of traction and a lot of developers interested into this particular set of applications.
So we talk about on-device AI quite a lot on this podcast, but to recap, I mean, what do you think are the biggest challenges with AI at the edge, kind of from the developer's viewpoint today?
I think from the developer's point of view, part of the challenge is, am I going to be able to drive machine learning applications with a microcontroller, right? Because you need a lot of performance, right? And that performance also comes in the sense of a lot of operations being run. The other part is a little bit counterintuitive, right? But also you need low power, right? We're talking about consumer type of applications. We're talking about energy efficient needs. That energy efficiency is an absolute requirement and an absolute challenge for these type of approaches, right? Where you need high performance to run machine learning, but at the same time, you need low power, right? It might be able or might be hard for a developer to get a hardware that allows you to do that. The other thing that comes also, of course, when you talk about edge AI is latency and real-time response, right? And it kind of goes along the lines of have a high performance, but nevertheless, right, having that latency and real-time response comes with the fact that you perhaps don't have the time to go into the cloud, do the processing on the cloud and then come back, right? That's going to take some time. So having the actual processing happen at the edge is something that developers are looking into. The other aspect is security, right? Going ahead, again, taking things into the cloud, it might be susceptible to malicious attacks, but if you keep things at the edge, you might mitigate those malicious attempts of attack. On top of that, you would need to have some level of security or a high level of security in your end device, nevertheless, because everybody might be able to just get into your end device and just start the attack from there. So high security is also a key challenge and a key requirement that we're seeing from different developers. Last but definitely not least is the integration, right? When you're thinking about machine learning, you might need to have multiple models being running at the same time. You might need to have voice activation mechanisms. You may need to have audio type of capabilities, graphics, right? And then radar or multi-sense type of features or requirements. And this is something that we are seeing as key challenges, and this is something that we are addressing with PSOC Edge.
Specifically for things like speech and NLP that we're going to be talking about a little bit today, the latency is super critical, right? We need to make it feel natural when you're talking to the device, right?
Yes, that's a key aspect, right? Like, and I don't know if you have your smart home device at home.
I have Alexa, yes.
You have Alexa?
Yeah.
Just imagine, like, I have a 5-year-old, right? So that 5-year-old, he likes to talk to Alexa. It's challenging, and latency doesn't help, right?
Yeah.
So having those type of challenges, we can see it in natural language processing, right? And now having an edge device that can just process everything at the edge is something that is, I think is groundbreaking.
Absolutely. From Infineon's viewpoint then, or from your viewpoint, what are the major hurdles that you have to get over in terms of scaling this PSOC Edge microcontroller in the market?
Yep, we are changing the paradigms, right? Normally, when you think about embedded processing, right? Think about microcontrollers, think about microprocessor. You have a control core that normally does control type of operations, right? And you rely on the workforce or what you can do with that particular core. Now we are introducing hardware accelerators that are neural processing units, right? This is a different type of handling different use cases and scenarios, right? So first of all, coming up with a software or a set of software and tools that allow you to easily integrate those neural processing units into your workflow, into your development workflow is going to be a challenge, right? Then comes, of course, the technical knowledge that you need to have. Comes the support that a vendor such as Infineon needs to provide. The overall adoption, right? Because I think this is going to be the future, but you need to enable that, and this is something that we are putting a lot of emphasis in PSOC Edge and Infineon, and this is something that we're really excited to be here in this position today.
So you mentioned software and tool chain, which is critical. We're going to come to that a little bit later in the conversation. Because first, obviously, I want to come to my favorite topic, which is hardware. The PSOC Edge family, I know, has 2 different AI accelerators on chip. I was hoping you could tell us a bit more about these hardware blocks. Why do we need 2 different AI accelerators on chip, and what's the difference between them, really?
Yes, I mean, and when you start thinking about your use cases and applications, right? Let's stick to the voice type of use case, right? You have your always on device that might be battery operated, right? First of all, you may just do wake word detection and keyword spotting, right? And then perhaps it's going to be a quick interaction and nothing's going to happen. But then you may do a natural language processing type of use case, right? When you wake up your device, you start talking to that device in a natural way, and then the device comes back at you, right? Those are 2 different set of use cases, right? The first one is the keyword spotting, right? Like a pretty low complex type of use case. And the second one is a little bit more complex, a little bit more of a natural language processing that requires more processing capabilities. Having said that, we have come up with 2 different types of accelerators or 2 different types of neural processing units. One, which is the one that's going to address the high processing, the complex side of use cases like natural language processing, and that's what Ethos U55 tied with our Cortex M55 and our Helium DSP architecture is going to be able to bring. But we also have come up with a low complexity MPU accelerator that we have developed in-house and that we have called NN-Light. So NN-Light is an Infineon proprietary accelerator. It's designed to optimize the energy implementation, right? It's designed to optimize models for wake word detection or anomaly detection or low resolution computer vision and sensing. It will keep things quite efficient when it comes to the energy perspective. And if you require to just transition into the high performance, natural language processing vision, that's when Ethos U55 we has, more processing capabilities will be really handy. So that's different. That's a unique approach that we have taken at Infineon. And that's an approach that allows us to become quite highly energy efficient in the embedded designs.
So I said the PSOC Edge family has 2 accelerators, but there's actually 4 subfamilies, and not all of them have both. Maybe you could just talk us through kind of briefly what is the difference between the 4 subfamilies, which ones have both and which don't?
Yeah, definitely. So first of all, even though it's our first family of microcontrollers, we have already come up with 4 different variants of PSOC Edge, right? The 4 of them are going to have the NN-Light MPU accelerator because we believe that's going to be a quite efficient use case for battery operated type of applications for different types of use cases that you may have at your design. So E81 and E82 are going to have the NN-Light accelerator. E81 is going to be kind of like the baseline of our microcontroller family. If you need to add the graphics, that's where the E82 is going to be there, right? Some of the designs do not require graphics, and we understand that. You don't need to pay for having graphics components if you are not going to use them. But if you do require them, the E82 is going to be there. At the same time, right, you may not require hardware advanced AI acceleration or advanced MPU capabilities. So that's why we have come up with the E81 and E82. But if you do require advanced acceleration MPU capabilities, we have the E83 and the E84 lines. The difference between the E83 and the E84 is going to be similar to the differences to the E81 and E82, meaning E83 is going to have advanced machine learning capabilities, but it's not going to have the 2.5D graphics processing unit. And then the E84 is going to have advanced machine learning capabilities, is going to have the 2.5D graphics processing unit. And on top of that, we are adding an extra megabyte of SRAM for those vision and graphics applications combined into one microcontroller.
Got it. So for NN-Light then, your in-house accelerator, this is aimed at always-on applications. Can you tell us a bit more about how you manage the power consumption with that in mind? Is it fancy sleep modes, voltage and frequency scaling? Tell us about how you manage kind of wake-up events as well. I'm curious about how much power that block actually consumes as well.
Yeah, no, we have kept things quite highly energy efficient, right? Of course, in the architecture, when you look into the architecture of PSOC Edge, you're going to find a lot of different power modes that you can leverage, right? So we're going to have hibernate mode, we're going to have a deep sleep mode, we're going to have a sleep mode, and we're going to have a running mode, right? Within the running mode, you're going to find different frequencies that you can set depending on your requirements, depending on your needs. But if we can just stick to the wake word detection flow, right? If we can stick to that part, we relied on the NN-Light. We rely on the low power domain that we are featuring in PSOC Edge. We're talking about milliwatts, but low milliwatts, right? Single digits milliwatts to perform that wake word detection, to go with keyword spotting, with acoustic activity detection mechanisms, and rely on the NN-Light and rely on the analog and digital mechanisms that we have in the PSOC Edge architecture. So quite efficient when it comes to that acoustic event that is going to trigger the next stage in your flow. And if required, right, you can just turn on the high performance domain, the Cortex M55 that is going to be sleeping at that point. And if you absolutely require higher performance, if you have a use case that requires more processing, then you can turn on the Cortex M55 and you can, of course, turn on the Ethos U55 neural processing unit.
So do you have a figure for us actually on power consumption for the different blocks? So what's the minimum power consumption I can use to do an inference with NN Light in this always on mode?
Yeah, we have single digits of milliwatts. That's,
okay.
And it's going to depend on the use case. And then when you take things into let's put an example of natural language processing, then you're going to still stick to the milliwatts, right? Perhaps hundreds of milliwatts, but we're talking about the natural language processing. So, of course, there are different stages. Of course, there are different use cases. Of course, it depends on the optimization of the developer designs. But this is something that we're seeing just as a high-level numbers that we're seeing from our different blocks.
So is it up to the developer then to decide which part of the AI workload to run where, or with more than one accelerator on chip? How do you partition that workload effectively?
Definitely the developer has a lot of say into that, and we provide the tools and the mechanisms for the developer to make it easy. We also provide our own AI tools, right, that will allow you, or we come up with an optimization of these type of use cases and these type of scenarios, right? So, and we'll talk about more when it comes the time to talk about software, but we can take a specific use case, and then our machine learning software is going to optimize the workload, and it will allow you to come up with some basic recommendations from the code perspective. Of course, the developer can always decide, right? We have a pretty user-friendly interface from Modus Toolbox and DeepGraph, and then the developer will be able to just decide what will be the best workflow that will load, that will work for him.
Yeah. Yeah. So I can imagine a few use cases where it's like you switch on NN Light and then you switch on the Ethos, like maybe you're doing voice detection through to understanding the command or something. But I can imagine more use cases, especially with NLP, where it's like maybe I want to use Edge AI to wake up and do a basic query, but then maybe I want to fall back onto Cloud AI for something more complicated type of conversation. Maybe I can use the device's internet connection to access the cloud. Is that going to be possible with PSOC Edge, or how would I implement that?
It is possible. It is definitely something that the developer can leverage. Actually, what we are also introducing PSOC Edge is now the feasibility to run sophisticated language models, right? And we're talking about tens of millions of parameters on device with the high energy efficiency setup that I have talked about. And this means like everyday devices, right, from ovens to watches, can have a natural language capability without relying on the cloud, right? So users can benefit from this, what we call the zero data egress. That means that no private data is going to go into the cloud. They can leverage that because everything can stay at the edge. They can leverage the consistent low latency that we have also kind of already talked about. And then, of course, having a functionality even if you are offline. Of course, the being online allows you to come up with different setups with different scenarios. It allows you to even come up with over-the-air updates for your firmware and whatnot. But we are introducing a new paradigm, a new level of processing where you are being actually able to have a natural language processing without relying on the internet connectivity.
In terms of scalability, is there the possibility maybe I have my AI application in mind, but then as it develops, maybe I add features or something. Maybe I started on the NN Lite, and then maybe I realized I need to use the Ethos accelerator. Do I need to change my code to do that, or how scalable is my AI application within the same hardware?
It is quite scalable, and one of the really nice things that we have come up with on PSOC Edge is that full scalability that goes not only from the pin compatible perspective, from the hardware compatible perspective, but also from the software compatible perspective, right? So you're going to have your system relying on NN Lite today, for example, having an E81 type of microcontroller is going to do the keyword detection, is going to be doing the wake word detection. But you say right now, this is all I need. But if in the future you want to rely on this natural language processing, what we have defined as edge language models, you can just rely on the E83, right? Add pieces on top of your code with the help of Infineon, of course, and then just have a seamless transition from E81 to E83, not only from the software perspective, but also from the hardware perspective, and its plain compatibility options that we are providing with PSOC Edge.
Got it. So overall, hardware-wise, most of the big microcontroller players have AI-enabled microcontrollers, and most have either their own in-house AI accelerator or some are using ARM too. How do you distinguish the PSOC Edge family from some of the other microcontrollers that people might be considering?
Yes, really good question. One of the key aspects that we have is that high energy efficiency angle, right? So we have the ability to have a high performance domain with a Cortex M55, with Helium DSP, with Ethos U55, but we also have that ability to provide that low power domain with Cortex M33 running at a lower frequency pair and tied to our Infineon Light, right? So that will take things through in terms of energy efficiency, as I've already described. On top of that, we have also come up with the highest level of security for a microcontroller. And this is because of our secured enclave architecture. This has allowed us to achieve the PSA level 3 and level 4 of integrated secure enclave certification from the Platform Security Architecture Consortium. And this is the highest level certification being achieved by a microcontroller, which in today's world, security is quite important. On top of that, we have a unique HMI integration, and that's part of the pedigree of PSOC overall as a family. And that HMI integration now has evolved into have multiple analog offerings, multiple digital offerings, having graphics and having, of course, the different type of cores that I have already described. So that HMI integration is unique. And last, but again, definitely not least, is just what we have come up from the software side of view, right? Like the state-of-the-art software tools with Modus Toolbox, a lot of emphasis on Modus Toolbox, but now we have also have the support from DeepGraph, which is game-changing software that we are implementing, that we are pairing up with PSOC Edge, and this is also quite unique in the industry.
Yeah, I think it's time we touched on software. Like you're saying, software toolchains for Edge AI are this kind of constant area of strife or constant area for improvement for a lot of chip companies. So tell us kind of from the beginning, how did Infineon approach building this Edge AI toolchain? And tell us a bit more about DeepGraph as well.
Yes, definitely. So two and a half years ago, Infineon acquired a company that used to be called Imagimob. Now we have rebranded that Imagimob into a DeepGraph, and we have put a lot of investment into what we can develop or we can bring to the table with DeepGraph, right? So we saw that particular platform that the Imagimob team had back in the day, and we realized that that was going to be a pretty good complement to what we were thinking on bringing from the hardware perspective, right? So aligning PSOC Edge, Modus Toolbox, and DeepGraph will put us in a special place, and that's the reason why I'm so happy to be here. That's the reason why when we take PSOC Edge into production, we also came up with a lot of different products from DeepGraph as well, because they are complementing our offerings from the hardware perspective, but also now from the software point of view. And that alignment between DeepGraph and Modus Toolbox is also unique, because from the Modus Toolbox perspective, you have what the developer typically sees, right? That we have the drivers, we have code examples, we have the middleware, but now with DeepGraph, you have the AI angle that allows you to complement your solution, that allows you to come up with models, but at the same time, already having all the drivers and all the different needs that you may have from the hardware perspective as well.
So for Modus Toolbox and then DeepGraph, are they separate tool chains today? Are you planning to combine them, or how do they work together?
They're separate tool chains, or they're separate tools. Let's put it like that, right? So DeepGraph tools and it has a different set of categories that I'm going to go into just in the next couple of minutes. But from the deep graph tools, whether we're talking about Deep Graph Studio, whether we're talking about the Deep Graph Model Converter, whether we're talking about the voice assistant and the audio enhancement solutions, these tools are designed to generate content that can be used into Modus Toolbox, right? So when you do the programming into your device, you're going to rely on Modus Toolbox, but there's a deep interconnection between Deep Graph and Modus Toolbox. And we have taken it further, right? When you download the newest versions of Modus Toolbox, you're kind of have the ability to also download Deep Graph on the go, and they're gonna work really, really well together. Even though they're different tools, there's a nice synergy between Deep Graph and Modus Toolbox.
So if I am already working on Edge AI somewhere, I've got my own model, let's say, I can bring that into the tool chain, right? Or what if I want to buy or license a model from a third party? It's going to be easy for me to bring that along with me, right?
It's going to be easier for you. We also, as part of what we have launched recently, is the Deep Graph Model Converter. So what we have here is a software application for converting, optimizing, and validating AI models to run on PSOC Edge, right? So let's assume that you have a PyTorch model, right? You can use Deep Graph Model Converter, choose even between an easy-to-use graphic user interface or a command line interface, and adapt your existing model to PSOC Edge, optimize it, and have it ready to go, thanks to the tool of software tool of Deep Graph Model Converter.
If, on the other hand, I don't have much experience with Edge AI, and I am trying to do an NLP application or something, Deep Graph is Deep Graph still going to offer me the right place to start?
Yes, Deep Graph offers different layers of options for you, right? If you're starting from scratch, if you're starting from just, I want to start collecting data and I need help with that pre-processing, with that deployment of the model and that training of the model and the deployment of the model into the microcontroller, we have Deep Graph Studio, right? So Deep Graph Studio is a nice user interface that will allow you to have that data collection. But we have taken things even further, where we have also come up with solutions, and particular solutions like voice assistant, particular solutions like audio enhancement, where you can rely on what we have done already. And these are tools that will allow you to customize your design, right? So you can come up with your own wake word detection, where you can come up with your own keyword spotting type of words, put them together, put them in the tool, and our tool will allow you to just take that, come up with the model, the right model, and just deploy it into the microcontroller, in this case, PSOC Edge. So, easy to use, low complexity, and now you're going to be able to have a real voice type of device in your hands, I would say.
So the NLP capabilities, I think, are particularly intriguing. Could you kind of overall give us an example, putting it all together then, what kind of NLP application can I achieve on a PSOC Edge microcontroller? Remember, this is a microcontroller, but how complex of an NLP application can I build with PSOC Edge?
It can get pretty complex for a microcontroller. And we're talking about even having 25 millions of parameters being deployed in the microcontroller. And this is something that we are optimizing. This is something that we have come up with some benchmarking data. And even though it's a small language model, what we have defined as edge language model, it's quite powerful when we actually compare it to some of the large language models that are out there. So we are pretty proud of what we have come up with in this particular case. And if you start thinking about the target applications, right, and this is something that it's quite for me quite interesting to just see the developers who have smartwatches developers, right, that they can use a virtual assistant where you don't actually require a phone or network connectivity, right? You can have an assistant that you can rely on that edge language model with more than 25 million of parameters, and it's actually gonna work really, really well. On the same approach or on the same type of things, you can have a voice assisted oven and fridge. Of course, you can already define the type of commands that you're going to have in those type of scenarios, right? But you can make it in a natural language processing kind of way that will allow you to have a pretty nice experience with your machine that you have in your home. Same type of thing, but taking things into the factory automation, right? So think about the factory floor assistant with a voice-enabled industrial scenario, right? That's something that you can also bring with this set of small language models. I have developers working with smart healthcare devices, right? The patient may be at home and they just, perhaps they don't need network connectivity, and they just would like to know, what's their cardiac frequency at that point, right? And this is something, sort of the use cases that I'm seeing, quite excited, and now bringing natural language processing capabilities in a device such as PSOC Edge and a microcontroller. At the end of the day, it's quite interesting.
So if someone's listening to this and they want to test out PSOC Edge for themselves, what's the first thing they should do, or where should they go?
I would recommend them to go to infineon.com/PSOC Edge. And then from there, you're going to see so many different assets, right? You're going to have the ability to buy either of two boards, right? We have an evaluation kit where we have put all the different interfaces, we have put everything together to just leverage the full capabilities of PSOC Edge. We have also come up with a low-cost kit that we call the PSOC Edge E84 AI kit, that also is available now. That has a lot of sensors, that has radar, that has microphones, that has even the ability to connect to the display, and will also allow you to take things into the next level, right? That with the help of DeepGraph, with the help of Modus Toolbox, we are in a really good place. If you need more help, we have trainings, we have demos that you can just, deploy into the microcontroller, deploy into your board itself. So a lot of collateral has been created. That's the reason why I'm so excited to be here and being in this position with Infineon PSOC Edge.
I think that's the perfect place to finish. Thank you so much, Omar, for joining us today.
Yeah, no, thank you, Sally.
Thank you very much, Omar, for the interesting conversation about NLP at the Edge. This episode of AI with Sally was brought to you by our sponsor, Infineon Technologies. Thank you very much, Infineon, for sponsoring us. If you want to learn more about Infineon's PSOC products, DeepCraft, or Infineon's other embedded AI offerings, please check the links on the podcast page at eetimes.com. That brings us to the end of the episode. Please tune in again next time for more conversations around AI silicon and systems. If you're listening to this on the podcast page at eetimes.com, links to articles and topics we've discussed are shown on your left. AI with Sally is brought to you by Aston Core Media. The host is Sally Ward-Foxton and the producer is James Eade. Thank you for listening.